So I'm really excited today because I get to share the Lunch and Learn presentation with my colleague Christina Toms from the Regional Water Quality Control Board. Christina is an ecological engineer at the Water Board, and if you worked on any wetlands in the bay or the estuary or along the shoreline of California, you've probably worked with Christina. I'm really excited that I've been able to work with her over the past, I don't know, 7, 8 years on the
7, 8,
regional
yeah.
water, on the Wetlands Regional Monitoring Program. So for those of you who don't know me, I'm the lead scientist for the South Bay Salt Pond Restoration Project. And half of my time is spent on the project and half of my time is spent working on projects at SFEI that have been both in the Bay and the Delta, but especially working over the past few years on the Wetlands Regional Monitoring Program, or the WRMP as well, you'll hear us call it. So Christina, not only has she been the chair of the TAC for the WRMP, and we've worked together as on that project, but she has been one of the people that was instrumental in really shepherding the WRMP through its early phases and getting it to where we are now. So I'm really excited to share this time with her. Christina's going to talk about the WRMP specifically, and then I'm going to follow up her talk with some some examples of how the salt-based salt pond or the restoration project is benefiting from the work that we're doing to collaborate with the WRMP. So we'll have two talks, one right after the other, and then we're asking to hold questions until the end. We have a lot of slides to get through. Christina thinks I have too many, so we'll see. We'll talk fast. And hopefully at the end, we'll have time for all of your questions. So really, it should be a fun talk today. Sit back and enjoy, and I'll pass it off to Christina.
Hi, everyone. Donna, thank you so much. It has been one of the terrific joys of the last 7, 8 years of my career to develop this program with Donna and so many of the other wonderful WRMP folks, but especially Donna. She's the WRMP mom, and I love her for it. So I'm going to provide a really broad level overview of the WRMP. Many of you are hopefully at least somewhat already familiar with the program. For those who are new to it, we'll try to not dive too deep into the details, but just really want to lay the groundwork for why this program is so critical and particularly how it's delivering benefits for the South Bay Salt Pond Restoration Project. So, I think we're all aware that monitoring is hard, right? Monitoring is the unsexy thing. Folks love to fund and implement restoration projects and develop these incredible visions of how we can improve the health and the resilience of the San Francisco estuary. But when it comes to actually learning what's working and what's not working, that can be really difficult. And a lot of existing monitoring, I think it's safe to put it into three types of buckets, right? So you've got ambient monitoring, that's kind of that long-term landscape scale monitoring that's being done by mostly government entities. So you have NOAA who's monitoring tides and the US Geological Survey who's monitoring stream flows. You have the Bay RMP that's for over 30 years has been monitoring water quality throughout the bay. And so, that's kind of the big background level of monitoring that we have going on in the estuary. Then you've got special studies, right? These are kind of more short-term, question-driven monitoring. Sometimes it's done as part of a research project, someone's master's thesis or doctoral dissertation. You've got programs like the Bay RMP, the South Bay Salt Pond Restoration Project, IEP that all fund special studies to address specific questions. And then there's permit required monitoring. Most every single restoration project in the estuary has to get permits generally from 6 different state and federal regulatory agencies. And those permits usually come with conditions that require monitoring. And all of these three buckets of monitoring they utilize different indicators, different SOPs or standard operating procedures or methods. They're often not coordinated across space and time. So you have some monitoring that's done at a landscape scale, some monitoring that's done at a site scale, and the two programs aren't really talking to each other. And what this monitoring is doing is it's developing a lot of data, but it's not necessarily developing a lot of information to inform decision makers like project funders and land managers, implementers, project designers, and regulatory staff, such as myself. And of course, all of this is really expensive, right? So we're all trying to do the right thing, but we're doing monitoring in different ways. We're spending a lot of money and we're not necessarily getting the answers that we need. Enter the Wetlands Regional Monitoring Program. And this has been a dream of the San Francisco Estuary Tidal Wetland Restoration community for decades. There were earlier iterations of this, the breach efforts in the 1990s, the Integrated Regional Wetland Monitoring Pilot Project in the early 2000s, which I had the opportunity to work on. For a long time, folks have been wanting a coordinated regional tidal wetland monitoring program. And we finally have had the opportunity to develop it thanks to this funding from EPA and the San Francisco Bay Restoration Authority. So, what does the WRMP do? It delivers coordinated regional monitoring of the estuary's wetlands to first inform science-based decision making for wetland restoration and adaptive management. What should we be doing differently? What could we be doing better? Where should we be doing it? We're all, Measure AA is we're taxing ourselves. We are the only estuary in the country that is taxing itself to raise revenue to fund habitat restoration projects, and we want to make sure that that money is being spent in the most effective manner. And we want to increase the cost effectiveness of permit-driven monitoring associated with wetland restoration projects. We want that permit-required monitoring to be easier, to be more effective, to be cheaper. So the program is co-managed by the San Francisco Estuary Partnership and SFEI, and you're going to see this URL, wrmp.org, a lot today. So, our vision for the WRMP is to really coordinate those three buckets of monitoring and not necessarily, in fact, very explicitly not do all of it, right? There's no way that the WRMP is going to be able to handle all of the ambient monitoring, all the special studies, all the permit required monitoring, right? There's always going to be special circumstances, new questions that come up. But the vision is that the WRMP coordinates these different types of monitoring using consistent indicators and methods throughout the region, that we're coordinating across scales, regional and site specific. We have a central data management hub that facilitates easier analysis and visualization of data, and that allows us to turn that data into information for end users. And we want this to be cheaper and more cost effective than all of those three different buckets operating independently. So we've been in development for a long time. We've had multiple rounds of wetland program development funding from US EPA, for which we are incredibly grateful. And that really long ramp up time allowed us to develop a science framework that really centers the information needs of end users. And I want to emphasize that point because I think a lot of the earlier regional monitoring efforts, including Breach and Irwin, they produced a lot of data, but not necessarily a lot of information. They were very academic exercises, and I think they struggled with translating data into information for project funders and implementers. And so that's something that's really been at the heart of this effort. So we were in program development until roughly like 2020, 21, 22. And then with our latest rounds of funding from EPA and the Restoration Authority, we've really shifted from program development into program implementation. We developed the science framework and now we're putting it to use. So our partners include pretty much all the major players in the estuary habitat conservation and restoration communities. We have a steering committee that's composed of project funders, regulators, the real decision makers, and then we have a technical advisory committee that's made of representatives from those same organizations, along with a lot of science institutions. So folks like the U.S. Geological Survey, National Estuarine Research Reserves, universities, SF State, University of San Francisco. I see John. John is here. Great to see you, John. And our technical advisory committee also manages a number of work groups. I'm going to talk more about those work groups in a second, but those are focus work groups on particular technical topics that include folks from an even broader cross-section of technical organizations, including consulting firms. And again, the program is co-administered by SFEP and SFEI. So, the who, what, when, where, how, why, what, huh? What are we doing? Why are we doing this? What? It's a lot. So, again, having a science framework that's focused on information needs. So, these are the guiding questions that drive the science of the WRMP. So, first, where are the region's tidal wetlands and wetland projects? What are the net landscape changes in area and condition? How are external drivers like climate change, sea level rise, development pressure, changes in watershed runoff and sediment supply? How are those external drivers affecting tidal wetlands? How do the policies, programs, and projects to protect and restore tidal wetlands affect the distribution and abundance and health of their dependent biota, so plants, fish, and wildlife? What new information do we need to better understand regional lessons from wetland restoration projects? What should we be doing differently in the future? And how do the policies, programs, and projects to protect and restore tidal wetlands benefit or impact public health, safety, and recreation? So our science framework has a lot of elements. We have a master matrix that is this, for folks that know me, they know I trained under Stuart Siegel, so everything goes into an unwieldy giant spreadsheet. But that spreadsheet, that matrix, it really is the heart of our science framework, and it helps us translate those guiding questions and those management questions into monitoring questions, indicators, metrics, and SOPs. We have conceptual models that help us understand what we should be monitoring, help us understand how are biotic and abiotic indicators related to each other, what are potential thresholds of change that we should be paying attention to. We have a monitoring plan that describes a framework for cost-effective monitoring and data synthesis across scales and across the entire region, and a data management strategy that allows us to not only analyze data that the WRMP is collecting, but really leverage all these other monitoring efforts, those ambient, project-specific, and special studies that are happening throughout the region. So here's this kind of complicated flowchart, but all I want you to get out of this is that this is an example of all the different biotic and abiotic indicators that the WRMP is tackling and how they relate to each other. And really key here is identifying those thresholds of change. Because if we can identify those thresholds of change, then that tells us where we should be doing interventions to help preserve and accelerate, to help us preserve existing tidal wetlands and accelerate the restoration of, of tidal wetlands throughout the region. So I mentioned earlier that the TAC manages a lot of work groups. Those technical work groups have all developed specific SOPs or methods documents that allow for consistent monitoring of biotic and abiotic indicators throughout the region. These are SOPs that can be used by anyone, not just the WRMP. The idea is that we got all these experts together to determine what is the most cost-effective manner to monitor these key indicators. So we have established work groups and SOPs for fish and fish habitat, for vegetation communities, for hydrogeomorphology, so that includes tidal inundation, water quality, suspended sediment, things like that. Geospatial, so that's remote sensing and mapping of tidal wetland habitats, and people in wetlands, which we'll talk a little bit about later. We're also in the process of establishing work groups for birds in coordination with the State of the Birds effort. And we anticipate, hopefully later this year, beginning to launch our mammal work group so we can understand how we can support our wonderful fuzzy friends, the salties, and their allies. So again, our science framework is focused on turning our guiding questions, our information needs into specific monitoring protocols. And so as an example of that, here's one of our guiding questions. How do policies, programs, and projects to protect and restore tidal marshes affect the distribution, abundance, and health of plants and animals? Well, we can translate that into a management question. How are fish and wildlife habitats changing? Well, let's turn that into a specific monitoring question. What is the distribution and abundance of tidal wetlands, and how is that distribution and abundance changing over time? That gives us our metrics. We want to map baleen habitats and map special status species habitats, how they're changing over time. And that gives us our protocols. So again, those are our SOPs that were developed in this case by the Geospatial Work Group, which developed our SOP for remote sensing and mapping of wetland habitats. And then our work group for vegetation, which developed our SOP for vegetation monitoring. And this is you can also see this is the CRAM SOP, which we'll talk about in a little bit. So all of these together, all of these methods documents developed products for us that can help us address this guiding question about how our tidal wetland restoration projects and programs are affecting the distribution of our dependent biota. So where That's another thing. Where is the WRMP working? So we've identified priority monitoring site networks. We're a, we're just a little baby program. We're just growing. So we can't do everything everywhere all at once. So we've identified some key priority geographies for us to monitor. And they're shown in yellow here. Those are our primary networks, and then our secondary networks are shown in orange. These networks provide geographic coverage across the estuary in all of its subregions. They address our guiding questions and our program's near-term science priorities. These areas give us the ability to leverage historic and existing wetland monitoring efforts that are in those three buckets that I mentioned earlier. These geographies allow us to collect data and develop information that can inform existing and planned tidal wetland restoration projects and support climate change adaptation planning in underserved communities. And that's a really key point here that I want to emphasize. While this is a tidal wetland monitoring program, really a lot of the indicators that we're monitoring are applicable to a range of nature-based solutions for shoreline adaptation. And so we really want to develop information to support restoration of natural communities, but also support the protection and the health and resilience and vibrancy of our built communities along the shoreline. So our monitoring sites, we have three types. The first is benchmark sites. These represent our mature, mostly ancient marshes. We don't have too many of them left in the estuary. Our reference sites, those are also older marshes. Maybe they're older restoration projects or they're centennial infill marshes, but they represent more likely target conditions for restoration projects than our Holocene ancient marshes. And our project sites, they reflect a variety of design and management approaches. So maybe they beneficially reuse sediment, maybe some didn't. Maybe some have big, extensive ecotone levees and others don't. We're, really trying to capture the range of projects in the estuary. So as an example of a monitoring site network, this is our proposed network in the Eden Landing complex in the Alameda Creek Operational Landscape Unit. So we've got a benchmark site at Whale's Tail South. That's an ancient, remnant ancient marsh. A reference site at the older Cargill mitigation site, and then active restoring tidal wetlands within the South Bay Salt Pond restoration project. So we've got North Creek Marsh, Pond E9, Mount Eden Creek Marsh, a whole suite of them, which Donna is going to talk all about in a little bit. And our science framework includes three types of monitoring. So we've got level one, which is remote sensing and mapping. That's landscape scale assessment. Level two, which is our rapid site assessment. So that's CRAM, California Rapid Assessment Method. And then level three is intensive assessment. This is intensive, what we would typically consider our field monitoring at a project or at a wetland. So one of our first deliverables that we're super excited about from our level one monitoring is the 2020 Baylands Habitat Map. This is the first high resolution mapping of habitats in the lower San Francisco estuary since 2009. The WRMP developed it using automated, consistent, and repeatable computer-driven methods. This is not heads-up digitizing. We wanted to develop a process that could be repeated that would minimize user error and give us a more accurate sense of how these wetlands are changing over time. It employs a standard habitat classification scheme that we developed through the TAC. And we anticipate updating this map every 3 to 5 years. And we're going to talk about a planned update to this in a little bit. But also these methods can be applied outside of the Bay. And we're already in talks with our partners throughout the state to see how we might be able to pilot application of this monitoring protocol outside of San Francisco Bay. The Baylands Habitat Map really highlights the importance of regular, consistent mapping. This allows us to highlight expected changes and see where changes are occurring on the landscape so we can identify potential interventions. So, for example, this regular mapping has allowed us to understand pan expansion and erosion of existing tidal wetlands along the Highway 37 strip marsh. It's allowed us to track restoration project in the Sonoma Creek Baylands as more and more restoration projects there have come online. And it's allowed us to track wetland expansion in the admittedly few places it's happening, but one of them, for example, is Calaveras Point near the South Bay Salt Ponds. That's, an area where we're seeing progradation of marsh and conversion of mudflat to tidal wetland. And without regular mapping, you're just not going to capture this. And this is really important to give us a regional picture of the health and abundance and condition of all of the region's tidal wetlands, including all the restoration projects. So if you're doing a project in San Francisco Bay, it's getting captured by the Baylands Habitat Map and its updates. We're also using the Baylands Habitat Map to identify wetland management units. This is a little bit of a weird map. It makes it look like Alex's face is like a pimple all over the North Bay. Just disregard that part. But this is an online mapping platform felt that we've been using to work with land managers and other experts throughout the Bay's subregions and identify wetland management units that allow us to track change within tidal wetlands at a scale that's kind of intermediate between all of San Francisco Bay and each individual restoration project. This Baylands Habitat Map has also allowed us to extract landscape resilience metrics. And if if you haven't seen Jeremy Lowe or Ellen Plain at SFEI talk about the Baylands resilience metrics, highly recommend you check that out. It's a really extremely technically rigorous way of looking at the landscape, looking at individual marshes, and looking at physical factors that influence how we can be managing them and how we should be doing restoration moving forward. The Baylands Habitat Map has also allowed us to develop a new analysis of the success of tidal wetland restoration in the lower San Francisco estuary and track the recovery of tidal wetland acreage over time. If you haven't seen the webinar that April did from SFEI about a month ago or month or two ago, check it out. It's recorded. But they've updated their project tracker to really get a sense of within very precise footprints of restoration how much wetland acreage we're recovering, and it's really really impressive. We're about halfway to our goal of 100,000 acres of vegetated tidal marsh in the estuary, which is really exciting. And coming soon, new LiDAR data. So we're updating the 2020 Baylands Habitat Map in 2025 with the first estuary-wide LiDAR since 2010-2011. We're planning on collecting it this summer. It's going to include the entire San Francisco estuary, not just the lower estuary, but the upper estuary as well. Going to be a low tide collection, and we're going to make that data freely available to all program partners, including the general public. We're doing CRAM, mentioned level 2 data collection. We're doing CRAM throughout the region, focusing a lot on restoration projects, getting them in and assessing how they're doing relative to the habitat development curve for tidal wetlands in the estuary. I'm going to go through this fast because we're running out of time. And also doing a lot of intensive level 3 monitoring of our wetlands, which Donna's going to talk about, all the site-specific monitoring that the South Bay Salt Pond Restoration Project is doing. And I think with that, I'm just going to skip the examples so we can go, that's right. And then I'll really quickly, people in wetlands. We're developing a framework for thinking about how people in wetlands interact on the landscape. Thinking about how people are involved in decision making about restoration projects, who's visiting restoration projects, how they're participating in stewardship and education, and developing information projects that evaluate the equitable distribution of projects and their benefits to people, and specifically how wetlands are helping to attenuate wave energy and reduce flood risk along shorelines. And so I think with that, I'll hand it off to Donna, who can talk about how the WRMP is supporting the South Bay Salt Pond Restoration Project.
That's terrific. Thanks, Christina. We're going to fly through these next slides. We hope. So next slide. There may be some people on the call that aren't as familiar with the South Bay Salt Pond Restoration Project, and I'm going to refer to it as the Restoration Project for the rest of the talk. But the project started in 2003 with the acquisition of over 15,000 acres of former commercial salt ponds from Cargill. We spent a few years planning and organizing for a 50-year project and started actual restoration in 2007. And here we are in 2025. I think what's the math? It's 22 years later. Next slide. So the project footprint is shown here. The areas in blue are owned and managed by California Department of Fish and Wildlife. The areas in green are owned and managed by U.S. Fish and Wildlife Service, and we call them different things. The blue are the Eden Landing Complex. The areas in green we named the Alviso Complex, and the areas in green near East Palo Alto are the Ravenswood complex. And areas in pink and orange are still owned and managed by Cargill. Next. At the beginning of the project, we had a lot of questions about how the habitats and the species would respond to restoration. A lot of birds came to use this site, use those commercial salt ponds over time. And so how would they fare once we started restoration? How were we able to create habitat for some of our endangered species and for species and for fish communities that would respond to the restoration as well? And then how would marshes establish? Would we have enough sediment in the system to be able to have marshes established? Next. So to help answer some of those questions, or most of those questions, the project developed a really rigorous adaptive management plan. Dave may remember that I think there's 22 or 24 project elements, or project objectives that we're trying to evaluate over this whole 50-year period of time frame of the project. We set a number of restoration targets for each of those objectives, and then a way to monitor and determine a scale and time frame for monitoring and making decisions on how the monitoring results turned out. And then we set management triggers and describe some applied studies and potential management actions that we could take to adapt over time. Next slide. So as Christina kind of laid out, these are just an example of some of the objectives that we're trying to monitor, and that doesn't include our permit required monitoring, which is for both phases of the project so far has been another extensive set of monitoring. And all that costs money, right? And monitoring funds are hard to come by and competitive. And then our monitoring, what we've been learning over time is that it's difficult to place our monitoring within a regional context. So we can monitor our sites and we can monitor the spatial scale of the project, but how do those monitoring results relate to the larger estuary? Next. So I just want to describe today some of the benefits of our collaboration with the WRMP and some of the early ways that the monitoring overlaps or extends our monitoring and some of the cost savings. And I can identify a few of those for that the project is experiencing through the collaboration. And then while maybe they don't directly overlap, some of the monitoring may help answer some of our adaptive management and permitting questions and help us kind of address that broad need for understanding at a broad spatial scale. And for us, there's been a benefit just in the collaboration with regional science through some of the governance structures, through Dave's on the steering committee, I'm on the TAC, and it helps us stay in contact with a lot of scientists doing this work and the regional collaboration. Next. So I'm not going to talk about all the adaptive management elements, but I'm just going to try to cover a handful and describe some of the benefits we're receiving. So keep going, Christina. Thank you. One more. So habitat establishment, or habitat, is one of our adaptive management elements, and we're particularly interested in the target towards a vegetation acreage and density for the project, what the species composition looks like, and how much mudflat channels, ponds, and transition area are being either restored or affected. So early on, the project contracted with Brian Fulfrost and Associates to do a habitat evolution mapping project to really talk about really map the habitats in the lower South Bay, not only just for the project, but the South Bay region around our project. And then we repeated that work again in 2019 and 2011. And it's really thorough mapping project that mapped not only the habitats, but also the species. Next slide. And so I'm going to try to go through these. It's like, what are our questions? What are we doing? What are the WRMP questions? And what is the WRMP doing? And how are we collaborating? The WRMP, Christina shared some of this, so I won't go into deep detail, but we're also interested at the WRMP level in habitat types, what types of marshes, what types of dike baylands, tidal flats, levees, channels, pans, and also the extent of estuarine and terrestrial transition zones. So similar types of questions. Next slide. And she briefly described the habitat map. It's been beneficial. It's a beneficial tool for us if we think about the use of the habitat map to track restoration progress, and particularly marsh gain and loss and vegetation coverage. And to address this, sorry, not next yet. So we actually have contracted with SFEI to in this next iteration of the habitat map. So we're contracted with SFEI to do a crosswalk between the prior Full Frost and Associates habitat mapping and the 2020 Baylands habitat map to develop this crosswalk, and then that'll give us a sense of how the two methods compare. And then we'll use that crosswalk to help address change over time in the 2025 upcoming 2025 Baylands habitat map. And I'll just say that we won't be mapping species in the way that Brian Full Frost method did, but we will be able to track all the habitats that are important to us. And I think it's going to save us a considerable amount, the benefit of saving us a considerable amount of money in terms of looking for funding for this work. But this work is going to be repeated every 3 to 5 years. So it's going to give the project a more frequent opportunity or snapshot to look at the habitat development. Now you can go to the next slide. So, and these we're going to step through really fast, but the other benefits of that contracting and that work with SFEI is that we'll be able to take advantage of some of the metrics that they developed for that project and the WRMP. So keep going through these, such as tidal marsh extent. Christina shared this on elevation capital. We'll be able to look at where our marshes are in terms of a specific datum, which will be really valuable. And then another metric being developed is the unvegetated to vegetated ratio, which doesn't correlate directly to percent cover, but will give us an idea of how much the marshes that we're restoring are vegetating. And then another collaboration is the SFEI staff and WRMP scientists are collaborating with Geosciences Australia. And Geosciences Australia is developing a model to match tides with satellite imagery. And they're really interested in how the model applies to other habitats around the world. And so we've been developing a partnership with them in order to see if we can apply that model to San Francisco Bay, and has a really great potential for us to be able to potentially look at development of mudflats or changes in mudflats that would help us on our project, one of our questions. Next slide. So we'll talk a little bit about estuarine fish next. For our adaptive management plan, we're interested in knowing how we're progressing towards a target of enhancing the numbers of fish and adult fish and juvenile fish in the areas where we're restoring marshes. So a lot of these next slides are slides that Levi Lewis shared in his Lunch and Learn a few months ago, and also some that he shared to the Wetlands Regional Monitoring Program TAC in a recent meeting. So the Salt Bomb Project's been monitoring fish since the inception of the project, and a number of you are familiar with some of the early surveys by UC Davis and Jim Hobbs. More recently, we contracted with Levi Lewis and UC Davis to actually develop kind of a synthesis of all the studies that have been done to date in the Lower South Bay, and then to kind of analyze how we're doing, or how the restoration project is affecting fish communities and how fish communities are responding. And so that work is in draft form and hopefully should be finalized in the next month or two and up on our website, so you'll be able to see that. So moving. The WRMP is looking at similar questions. How do policies, programs, and projects protect and restore marshes that affect the distribution, abundance, and health of fish? And then how are those habitats for resident species of fish and wildlife changing over time? And how are the distribution and abundance of fish and wildlife of tidal marsh systems changing over time? Next. So the WRMP has developed a whole program around regional fish monitoring that is beginning this year, the actual in-bay monitoring happening this year. And for the first time, it will be a whole Lower South Bay program to monitor fish, which is really exciting because we've never had a one-time effort to look at the abundance and distribution of fish. Levi's team and the UC Davis team have developed a Wetlands Regional Monitoring Program guideline for monitoring fish and fish habitats, and they'll be using that. They've started using that to implement fish monitoring in the bay. And then the work that they did with the South Bay Salt Pond Restoration Project on this fish synthesis will provide a really good opportunity to help develop a fish synthesis that's a regional synthesis for the bay. So a lot of overlap in kind of the efforts that we're all working on together. Next slide. So this is the extent of the fish monitoring that the regional WRMP regional monitoring will be doing. You can see focused a lot on areas in the North Bay near restoration projects, and then Luckily for us, fortunately, there's a focus on the areas near our Eden Landing Complex and in the lower South Bay. So a lot of monitoring that will be happening that will provide some great information for our project. Next slide. Christina showed this slide of project reference and benchmark sites. So next slide. And this is just an example of where the fish monitoring team will be monitoring that overlaps with those network sites. And as you can see, there's a lot of monitoring that's being added for the Eden Landing Complex. And in the South Bay, let's see, I'm going to do a little side note. Someone asked if Coyote Triangle Marsh was a benchmark site in the chat, but Coyote Triangle Marsh is a reference site in the lower South Bay complex. So this is just a sample of where the monitoring is happening. And I guess I just want to point out, we'll be talking about vegetation and other elements, and you can just get a sense of where all of that monitoring is being focused. Next slide. And this is where the monitoring is for the fish, WRMP fish monitoring. And you can see that there's a number of sites that are being added to what the existing monitoring that their team has been doing for the South Bay otter trawl surveys in the lower South Bay. So it's just a little bit of an addition to that work, but extensive and covers a lot of our project area. Next slide. And just to highlight that they are monitoring outside of Pond Bay 6, and also you can't see it in this photo, but along Calaveras, I've added a site along Calaveras Point. Next slide. So all of these results we'll be posting on our website as they become available to us. An example is they recently did a bunch of otter trawls in Eden Landing, and now that information was included on their Fish in the Bay website. If you don't follow that website, you should. Jim Irvin and Jim Hobbs are curating that site right now, and it's really fun to see all the fish and learn about all the invertebrates, and usually a fun story or song at the end. So you want to be sure to catch that. And the WRMP will be posting all of that information and data eventually as the data becomes available. So, you know, for us, it's a really great way to kind of understand what's happening with the fish communities in our project area. And then as we're being required to monitor, we can hopefully make some kind of connections with the monitoring that the WRMP is doing. So next slide. Keep going, one more. The big question I think that everyone asked at the beginning of the project was, will our marshes have enough sediment? Is there enough sediment available in the bay to help us reach marsh plain elevations and colonize? The other big question was the concern that, you know, that any sediment in the system that would help build those marshes might be taken away from areas like intertidal and subtidal habitats, such as mudflats. So there was a big concern. And so it's one of the adaptive management questions that they've been working on answering. And also that establishing marshes wouldn't cause any kind of loss of vegetated established tidal marshes. Next slide. So a lot of you remember early in the project did a lot of sediment accretion monitoring at the island ponds early on and at Pond Bay 6. And I just, a side note, I love this slide because I'd forgotten, you know, how sort of gypsum and hardcore the marshes looked like back in 2006 before they were restored, and they're now verdant marshes. So a lot of John Calloway's team and did a lot of that work at Island Ponds, and then collaborated with H.T. Harvey at Pond A6 to do work there as well. So next slide. Take us back in time. They did a lot of work to install sediment pins versus not SETs at the time, and then to install feldspar marker horizons to measure accretion over that. So next slide. I won't go through these, but Christina went through these really well, but similar questions. How are the ecosystems changing? Are marshes restoring? What is sediment and runoff? How does that affect the establishing marshes? And what can we learn from, I think this is an important thing for us thinking about a project, is what can we learn from the marshes that are ongoing, and how can they help us advance the science and the continued restoration of other projects? So Karen Thorne's team at USGS is using surface elevation tables, or SETs, to monitor marshes and to measure accretion and elevation change in a lot of estuarine marshes in the Bay and the Delta. And if you're not familiar with SETs, it's a way to measure elevation change by using a large rod pounded into the marsh to measure what's happening below ground and combine that with a feldspar marker horizon, which is basically a clay on the surface, and to measure the accretion above that clay surface. And so those two measurements together can give us a sense of elevation change and how marshes are changing in the bay. And the WRMP, oops, back one, the WRMP network is shown on the right, and that includes some sites that the South Bay Salt Pond Restoration Project and U.S. Fish and Wildlife Service collaborated on to have installed in the lower South Bay. So that whole set of sites that you see in the lower estuary were sites that we collaborated with USGS on. And those have now been incorporated into the WRMP SET network. And so that work is now funded by the WRMP. So it's just, there's a couple examples of that for us where work, we started some work and now it's being carried on by the WRMP, which is a really cool collaboration. And it's the cost savings for us, but it's also benefiting the region. Next. An example of that for us, we restored Pond R4 at Ravenswood in December 2023, and USGS installed, let's see, 4 sites there. Yeah, 4 sites there right before the breach, I think maybe 2 weeks before the breach. And the restoration project funded the installation of those sites and then funded monitoring directly afterwards and 6 months later. And now those sites are incorporated into the Wetlands Regional Monitoring Program SET network. So a really cool example of how projects can maybe not pay for everything, but pay for portions of the monitoring and then have the WRMP partner on future monitoring. Next slide. I'm getting there. That information is going to be helpful for us. We can compare it to some of the other regional monitoring in the lower South Bay. Next. And also compare it with results from that similar type of monitoring throughout the estuary. Next slide. Keep going, one more. So also thinking about habitat establishment and our tidal marshes, the WRMP is going to be doing vegetation monitoring for the lower estuary. Chris Janusek and Trevor Williams at Oregon State University are the scientists leading that work and being supported by Lisa Beers and Aviva Rossi, who are the lead scientists of the WRMP. And so last fall, they established 18 permanent sites in the lower estuary, sorry. Field-based permanent transects, so transect monitoring. And then the NER established 2 sites, transition zone special study sites, at Rush Ranch and China Camp to look at early change detection. And so those all were installed last year. I think there's still a couple to be installed this summer. And then the first round of actual sampling will happen this summer. And so a number of those sites, next slide, are within both our project areas or adjacent to, and we are also including Pond R4, which is the newly establishing site for vegetation monitoring. So we're not wholesale doing all the WRMP monitoring at our sites, but we are looking for opportunities where we can combine the efforts of the 2 efforts. So next slide. That monitoring includes wetland surface elevation, typical veg cover, composition and diversity, soil water salinity, and then interestingly, they are also adding sediment accretion along the transects, so adding feldspar marker horizon plots along the transects. So that will help support some of the accretion data that the USGS team is collecting at their SETs and give us a sense across the site for accretion. And then piezometers at a number of the sites. Next slide. Christina briefly showed a slide of CRAM, the California Rapid Assessment Method. It's a method to quickly assess condition at marshes, and a number of sites were installed last fall that include our restoration project sites as well as sites adjacent to ours. And these are a way for us to do a quick assessment on the metrics, on the attributes you see pertaining to landscape and buffer, hydrology, physical structure, and biotic structure. And as this site network grows, we'll be able to place our sites within the context of a larger habitat development curve and compare progress of restoring sites with other sites in the estuary, which is going to be super helpful. Next slide. See here, I did it. We're getting really close. So I guess I just want to reiterate that this is a really cool opportunity for us to collaborate with this WRMP effort. It's not only saving the project, the restoration project, but it's also benefiting the landowners associated with the project because we're getting monitoring at their sites as well. We have been able to find cost savings for our project and share resources. And I don't know, it's just to me, the broader sharing of monitoring efforts in this time when we're facing sea level rise and climate change is super important because it gives us a regional context for the things that we see on our site and helps us kind of place those in context of what might be happening overall. And we've had a number of examples of that for us where we have those questions, right? Like, how does this monitoring fit within climate change and sea level rise? And I think that's our last slide. Next one. Yes, it is. We managed to do 60 some slides in 45 minutes. I don't know. I mean, that was a rapid fire sort of presentation, but I hope it just gives you the flavor of how projects are going to be able to interact with the WRMP. It's not going to be one-on-one. We're not going to replace, the WRMP is not going to replace all the monitoring for a project, but there are going to be places of intersection where we can collaborate.
Well, that was excellent.
Well, it was fast.
Yeah, and that was really fast. I'm impressed. So thanks for the excellent presentation, Christina and Donna. Very nice as always. We still have 46 of our peak of 50 participants here, so I'm hoping we have some good questions or comments or follow-up thoughts. We so far we only have two in the chat that I'll cover really quick, and then we'll open the floor for anyone that wants to ask some questions live. One of the questions was about Triangle Marsh, just west of the railroad track in A16, and whether or not that's a benchmark site. And I honestly can't remember. I should know, but I don't.
I shared that. It's a reference site.
It is a reference site.
Yeah.
Okay. And then the other one was from Jillian Bogart about sharing the name of the group or the partner that's monitoring the tidal movements. And I'm not sure if that is a very obvious question.
I don't
Like, what's meant
understand.
by that.
Tidal movements like tidal inundation?
Yeah, Jillian, if you're still here, do you want to expand a little on your question?
Hi, sure. Thanks. Thanks so much for the presentation. Informative as these usually are. My question is about Donna. You had showed a graphic that showed how tides were affecting, especially in particular, the mudflats. And I think you were mentioning a partner or a potential partner in Australia. So I just find that's really fascinating. And I was hoping that you could share a little bit more about that, what that would look like, what kind of information that might bring to the project.
You want me to tackle that?
About this.
Yeah, this collaboration is all my fault because I discovered. So we're working with the DEA Intertidal team at Geoscience Australia. So in Australia, they have a very complex coastline and they have very few tide gauges. And so they rely on tide models to give them a sense of how tidal inundation shifts throughout their very geomorphically complex shoreline. And so what they've developed is a technique that takes that modeled tide data and pairs it with regular collections of satellite data. The satellites sense whether or not the mudflats are wet. It's because it's multispectral satellite imagery. So one of the things that the satellites can do is determine whether or not a given area is wet. And so those repeated satellite passes are then paired with the modeled tide data, and that's what DEA Intertidal does. And that's what develops that time series of mudflat change over time. What we're excited about, what the Geoscience Australia team is excited about, is that we don't have modeled tide data. We have actual tide data. We have an abundance of tide gauges throughout San Francisco estuary. And so we're pairing their software and their protocols with our actual observed tide data to get a sense of how mudflats throughout San Francisco estuary are changing over time. Does that answer your question?
Yeah, that's super cool. So it's DEA Intertidal?
DEA Intertidal, Digital Earth Australia, which is the team at Geoscience Australia, and it's their intertidal product. So if you just Google DEA Intertidal, it'll take you to their webpage.
Cool. And I guess that just relates to one of my other questions, which is about different kinds of resource use in the Bay and like people's use of coastal resources. So I know that historically there's been a lot of people who gather shellfish and things from mudflats and that sort of thing. So I was just wondering if there was any engagement with people who do that kind of thing in the Bay, or if there's a sense that people are still doing that or know where not to do that.
Yeah, I'll cover that really quickly. That's shellfish monitoring is done by the California Department of Public Health. So they're a different division of the Cal EPA than the water boards. We partner with them. The Bay RMP, the Bay Regional Monitoring Program, that's the Bay's primary toxics and contaminants monitoring program. The WRMP has partnered with them particularly on this issue of sediment because a lot of toxics and contaminants are bound to sediment. So if you have more questions about that, please feel free to follow up offline and we can talk about that.
Right. Well, thanks for those questions. Do we have others from the listening audience?
We talked them into submission, Christina.
You may have done so.
I did have that question on the Triangle Marsh. I was curious. I put it in chat, but I didn't hear a response.
We
It's
did
a
do that.
reference site. Yeah.
Coyote Triangle Marsh is a reference site. Right.
Thank you.
It's
Thank you.
it's largely Centennial Marsh. It is not an ancient Holocene marsh.
Oh, okay. Because that's when I do various talks, I talk about it as being, from what I could tell, not having been touched at least for 100 years, but I was curious.
There may be some interior chunks of it that may be vaguely Holocene-esque, but it's largely a Centennial Marsh platform.
What do you mean by centennial?
It's secreted in the last 100 years on sediment that's washed into the estuary from the delta.
Got it. Thank you.
Mhm.
I see a hand up from
Hey,
John
John.
Calloway. Hi, John. Thanks for being here.
Yeah, thank you, Donna and Christina. It was great. And I had a question. You mentioned the upcoming LiDAR that's going to happen across the whole estuary. What's the resolution on that? And are you going to be able to do the corrections for vegetation and everything? Because there's such a big difference in vegetation height and everything across the whole estuary.
Is Peter Alex on the call? They could rattle off a bunch of really technical attributes about the upcoming LiDAR collection. But it's state of the art. ND5, right? Or
Yeah.
NV5 is going to be
Yeah.
doing the collection. I think we're doing it to 3DP standards established by the US Geological Survey. So yeah, it's going to be really high res and really rad and awesome.
And they are going to be attempting a correction. So we're going to be getting people into the field to actually take measurements too. I think the NER is going to be helping with that. So yeah.
Great.
Oh,
Excited
Lisa's
to
on.
hear
Lisa
about
could
it.
tell us. Lisa
Yeah,
knows the
Lisa, yeah.
detail. Yeah.
Yeah, I just wanted to say it's going to be 12 points per square meter. So it's higher than anything else that's been collected within the Bay so far.
That's awesome. And Lisa, I didn't know if your hand was up to answer that question or whether you had a separate comment to make.
That was it.
Ah, that was it. Okay.
I just want to add, I don't think Christina shared it, but the 2020 habitat map and other maps prior have been developed using like whole sets of DEMs, different LiDAR collections and DEMs developed. So they're like patchwork of information. And this is going to be one set. I mean, I just can't go on and on about this enough. I talk about it everywhere, like one set of LiDAR for the whole estuary. It's amazing.
Our former colleague Pat Showalter. Pat, you had your hand up earlier. Did you
Well,
Did you
yeah,
answer your question coincidentally, or did you want to say something?
I was wondering if you wanted to opine a little more about thresholds of change.
I'm
And
so glad you asked that. I had the same question.
and, and then the other thing I was interested in is, early in the projects, the accretion rates were much higher than had been modeled. And, like the island ponds filled in a lot faster than we thought they would, which was great. But I just wondered how those accretion rates are changing. Are they still, are they are we finding they go along with the models now? We've redone the models, so they go with the models, or how are we keeping up with that?
It's so great to see you, Pat. It's
Hi.
wonderful. We did see really high accretion rates at Pond A6, which was, after the island ponds. When USGS did their recent SET measurements at Pond R4 recently, they measured accretion using the SETs, and I think it was 15 to 35 millimeters, but that was like immediately afterwards. So it was an inch or two away. They'll need to let us know if that's still, in their next set of monitoring, if that still holds. I think it does relate to where the sites are in the bay, in relation. The lower South Bay seems to have a really high sediment accretion rate. I think we're going to see a little bit less at Ravenswood, but still enough, we're still going to see the marsh develop there. So I think it's more related to location, but yeah, others might have ideas on that. And then,
Well,
Christina, did you want to answer thresholds of change?
Yeah, I mean, I think, Pat, the answer to your question is complex, and it's one of the areas that the WRMP is collaborating really closely with the Bay RMP on sediment. Understanding what's happening with sediment out in the bay and on the mudflats is a different animal than understanding what's happening with sediment in the marshes and in the channels. And what that looks like varies across the bay's different landscapes. It varies across seasons. The way that it's just really complex. And so we're collaborating with the Bay RMP so that we can get a better sense of what sediment supplies look like throughout the region, how they're changing over time, how they're changing between seasons. And so, that's one of the reasons why the WRMP is funding the installation of more SETs so we can broaden our spatial coverage. We're partnering with the Bay RMP to guide special studies. Jesse Lacey's team at US Geological Survey and Karen Thorne, we're working with them really closely. And so, that's a really key question for us. And it's really relevant to those thresholds and triggers because one of the biggest knobs and dials we can manage in the estuary is how we move sediment around. We have a lot of sediment that's coming out of our Army Corps dredging. We have local sources of sediment from watersheds. And so that's really key, is understanding where are the sediment supplies, where are they existing, where the wetlands are most likely to keep pace with sea level rise, and where are the wetlands going to need help and intervention. And so that's where those thresholds and triggers come in.
And just as a comment to make that, I serve on BCDC, and we are very actively working to update our policies so that we can take advantage of this science that you're learning.
Yeah.
And there's a really strong desire to maximize the use of the sediment that we do have to move toward the sea level rise protection, which is also wonderful habitat enhancement that we all need. So I just want everybody to know BCDC is working very hard on this, and it's never fast enough, but we are working on it.
That's why Brenda Gaydon is on our steering committee.
We appreciate those efforts, and we appreciate all of you for sticking around till 12 o'clock. It is the top of the hour and the end of our time together. So once again, thanks to the attendees and to the speakers and to everyone for making this stuff happen.
Thanks, Dave, for helping.
This recording of this and the slides will be on our website within a few days usually. So you can download them there. Thanks again.
Thanks.
Cheers.